So this is Intro to Arduino presented by Start Similarly. My name is Sion Bhatia,
And I'm Soho Watcha.
and today we'll just get into a new project and more exciting project um, compared to last time, which was more basic. And so yeah, well, once again, if you have any questions, go in the Q&A, type your question. We'll do our best to answer it throughout the class. But we also spend time at the end of class, like 5 to 10 minutes, to answer questions. Um, So if you have any major questions and it wasn't answered during the call, we'll make sure to answer it at the end.
Yeah, and then we went over this last class as well, but some future sessions for Intro to Arduino. Last week we had our first class. If you guys missed that, we provided the recording in our weekly email. But today is our second class. We have our third class next week, and then 2 weeks from now we have our last class for the Intro to Arduino series. And so today is the 30th of September. Next week will be the 7th of October when we have our third class, and then we end on October 14th.
All right. So another thing we wanted to point out was for people to just check their inbox because we sent the recording and as well as some other resources in our email. So we provide that through emails, which is our main form of talking to you guys. So if you have any questions outside of class, you can also email us back. But mainly, if you want the recording to the class or if you have any other questions, we either answer them through the emails or we send other information about the Intro Arduino program. So just make sure to check in your junk folder in case you haven't received it.
Yeah, and then today's session, what we're covering today, we're doing some exciting stuff. So we're going to get into just some review from last time for LEDs and what we discussed in last class. And then we're going to be going over what a breadboard is, variables, what is the time delay. And then the fun part is we're going to be building our second project, which is our multiple LEDs project. And then once again, as Sun mentioned, throughout all of what we covered today, if you guys have any questions at all, make sure to go up top, hit that Q&A button, type your question, hit enter. We'll make sure to get to you. Either we're going to address the question in front of everyone, or we're going to respond to you directly, whatever works best.
That is where that is why you are seeing this information because we collected this data. The second, let's say, statement about your profile is that we want you to make sure that everything that is there is the best representation of you. We might be missing some skills that you have used previous to Accenture, let's say, or that are very specific to your current role or your project, and we want you to reflect.
All right, sorry about that. I don't know what happened there. I think we accidentally promoted someone else panelist. Anyways, yeah, just as a reminder, we have this is a webinar, so not everyone can talk. You guys can't talk or show your video. So yeah, we're the only ones that can do that. But if you have a question, make sure to put in the Q&A, and that's the best way we can answer it. Unfortunately, you guys can't speak right now, but we're the only ones that can speak and share our video. Yeah, so as Sol said, we'll be getting to the multiple LEDs project, which is at the end of the day. Not the end of the day, but we'll be towards a little bit at the end of the class. But right now, we'll just quickly go over a few of the other concepts. All right. Yeah, so last time we went over what an LED is. And so it's just a small light. I think a lot of you guys know what an LED is because you have them in your house. But in our case, for Intro to Arduino or any of the Arduino that we work with, an LED is just a light. And when it's connected to the Arduino, like last time, we can turn it on or off using code.
Yeah, and then another thing, we didn't really state this and cover this too much over our last class, but if you do remember in our blinking LED project from last week, we did use something called a resistor. So just remember that a resistor, all it does is it conducts electricity. So that just means it controls it. So for example, I think I gave the example last time that one of the main purposes of the resistor is to make sure that our Arduino does not burn out. So that's all you really need to know. It just controls the electricity, make sure that our Arduino is not burning out. That's all you need to know.
And yeah, we also went over this last time, which is how LED is programmed. And so, as I said, the two modes of the LED is on and off. And the way the the Arduino understands it is by writing code. And so, in our case, we've typed in the code digital write. And so, part of digital write is to say you're telling the LED to turn on or off. Um, and so that's high or low. That's what high or low means. Low just means you're turning the LED off, and high means you're turning it on. And in our case, the digital write says turn on pin 1 because you can see at the end of the LED there are some rods, and those just basically um, allow electricity to flow into the LED, and you put those rods into a pin. Um, and they're connected to some pin in some way with wires or something like that. So to tell the Arduino with code how to turn the LED on, you have to tell him or tell it uh, to tell which pin to turn on or off. So in this case, it would be digital write 1 high, which would turn it on, which would turn pin 1 on, and pin 8 off.
Yeah, and then something that you guys may or may not be familiar with, and something that we're going to be using today, is something called variables. So this is just a good computer science topic to know in general. So variables are used in all types of programming. So all you need to really know about variables is you guys have probably heard of variables in science, right? So variables are values that can change. So for example, down below you can see at the beginning of anything, for example, we could have our variable called score have a value of 0. And then at the end of our game or our project or whatever we're working with, our score could be 100. So score in this case is the variable, and since the value changes, it is called a variable. So you guys have probably heard this like independent or dependent variable. That's probably used in science. So it's a very similar concept that we use in building with Arduino and programming in general.
All right, so this may be another concept that we kind of talked over and went over last time, and this is what we had in our code too. So on the left, you'll see on this PowerPoint slide, there's a line of code that says delay, and we used this last time when we told the program to um, turn on the LED and after 1 second, turn it off. Because turning it on and off is really quick, but you want it kind of delayed to turn it on, and then after 1 second, turn it off. After 1 second, turn it on. And so in this case, to do that, to set this delay and stall the code, we had to write a line of code that says delay, and inside we wrote 1,000. And I kind of went over this last time, but 1,000 is actually representing milliseconds. And it might be a little confusing, but basically 1,000 milliseconds is 1 second. So if you see delay 1,000, that would be 1 second. If you see delay 2,000, that'd be 2 seconds. Things like that. So it's just all the delay does is it waits that much time before moving to the next line of code. So if you were to turn an LED on, then it would wait 1 second and then turn the LED off. And so we'll be using this today, just like we did last time, but we'll be using it multiple times.
Yeah, and if you guys have any questions about what delay is or what it does, or if you're just super confused in general, please again feel free to go to that Q&A box, type in your question, hit enter, and we'll answer you directly. We really want to help you guys. So moving on, we're going to be talking and we're going to be using a component which we haven't really discussed, and you guys may have not heard about, but it's called a breadboard. And so all a breadboard is it helps us to make our own circuit. So essentially what we can do is we can have all the components we want, like an LED, maybe a motor, whatever we want to use with our Arduino, we can put them all together on one small board. And that board is called a breadboard. And so we can connect wires to it. We can connect LEDs, for example, resistors. We can connect all different types of components associated with an Arduino onto a breadboard. So all you really need to know is a breadboard helps bring together all components that we want to use with an Arduino. And we're going to be using a breadboard today in our multiple LEDs project.
All right, so that was just a few concepts before we get into our next, the final project for today. So quickly, I'll demonstrate how to do this one once again. We did this last time too, but if everyone could go to tinkercad.com/join, and so we'll type it in the chat so that everyone can quickly see that. Yeah, so we'll quickly type it in the chat so everyone can go there. And just go to tinkercad.com/join. So that and I'll tell you what to do from there. But basically, we'll be typing in the class code, and that's how you just log on. So, all right, yeah. And so some people have already logged on from before. It might have already saved your your login and the class code. But if you haven't already, just go to tinkercad.com/join, and there will be a box to enter the class code. And so the class code is on the screen. I'm sharing it right now. It's J6NK KLAF SVI4. That looks like a 1 or an L, but it's an I. So it's FSV1I4. And so just type that code in. I'll demonstrate how to do it after everyone else does it if some people have trouble. But I'll demonstrate right after people are able to finish it.
Yeah, and when you go to tinkercad.com/join, that will allow you to join the class. But if you've already accessed Tinkercad in our last class, all you really need to do is go down to the bottom where it says already have an account and click sign in. And then once you sign in, click join your class. And then from there, type in our class code, your nickname, which is your username. And remember that our link startstemearly.org/meet. You can scroll through that list and you can find your name and your associated username and then type that in and hit enter. The entire instructions for how to do that was in our last class and was in the recording that we sent out last week. But if you have any trouble at all with doing that process, go ahead and ask us in the Q&A. Or if you, for whatever reason, cannot find your username, you can also tell us in the Q&A and we'll make sure to get you guys set up. So Sun will go to the link right now, tinkercad.com/join.
Yeah, so I'll go to this link right here. If you've already done it, that's great. So once you're at this link, it'll prompt you to type in the class code. And I'm only going this again because some people might not have been here last time or are having trouble. Okay, I'm already logged in. I'll just quickly log out so see that. All right, yeah. So you should be here. You'll just paste in the class code or just type in the class code that we had mentioned above or that I shared. It's J6NK. Make sure you're just copying this down or writing it down if you're behind. J6NK KLAF SVI4. And we'll type it in the chat later in case anybody needs it. Okay,
yeah, and also the link that Sun has right now, that the tinkercad.com/join, where you can sign in or join our class, is in the chat, as well as the link to find your username/nickname is also in the chat, and then the class code is also in the chat. So if you guys have any trouble at all with which link to go to or what the class code is, it's all on the chat for the Zoom webinar.
Yeah, so now the next thing is just to get your username. If you remember your username from last time, great. Go ahead and type it in. Once you do that, you can click that's me. And that will take you straight to your projects and your dashboard from last time. and you can create a new project and view your project from last time. If you have not, you can go to startsummerly.org/me, find your name, and then on the left-hand side, it will be your username, your nickname. So once again, go to the right column, find your name, and on the left, you'll find your associated nickname. And last time we had a few people that did not have their nickname, couldn't find it because it was not on the list for some reason. If that is you, only if you were not able to, if you didn't have a username, go ahead and type it in the chat. Not everyone can see your question, so just type it in the chat. Ask us your question, or what if you weren't able to find your username, and we'll go ahead and make a username for you. So once again, go to the chat and type in whether or not you were able to. If you weren't able to log in last time because you didn't have a username, we'll make one for you right now. So just type it in the chat, and we'll make sure to do that. Yeah, so that's pretty much it. Just go ahead and type your username in, log in, and then so we'll get into how to do the next part. All right. Yeah, and so we'll go ahead and share his screen on and teach you guys how to start the hardware parts, and we'll go ahead and get right to the project.
Yeah, I'm just gonna wait like maybe 1 or 2 minutes for everyone to get set up, just get in. All I really want is just that people are on that screen where it's just a blank dashboard where they can create their project or whatever. Just make sure that you're signed in, and then you found your account. And if you have any problems with that, as Sun mentioned, go to the Q&A, type in your question, and we'll make sure to answer it and get you guys set up.
Some people are saying the code isn't working. Most likely you're not typing it right. Go to the chat and make sure you've done that right. It should work if you have typed in the entire code. We've also put in the chat above. So if you have, if you don't remember the class code, you can just go from there.
All right, so I'm gonna go ahead and start. We're gonna start building our multiple LEDs project. So if you just a little background on this project, what we're gonna be doing is we're gonna start using the breadboard to create a series of lights that can blink one at a time. So this will be a little more complicated than our last project, but we're gonna be using a lot of the concepts and the tools that we used from last week. So let's get started. I know someone already discussed this, but if you're having trouble, I'll go over it again. So remember, tinkercad.com/join. you can sign in from there. From here, just go down and click sign in. You then click students join your class, type in the class code. So the class code is, I believe, I typed in the chat. It's J6MK, KLAF, SVI4. I can join my class, and then I can just type in my username. So type in your username, and then you'll be on this screen, hopefully. So everyone should be on this screen, and if you are, that's perfect. You're at the right spot. So from here, I'm gonna go ahead and start creating my circuit. So remember that last time what we did is we go over to the left, we click our circuits tab, and then we click create new circuit. And then once we create a new circuit, we're essentially creating our new project. So you should be inside your project. It should be completely blank. And then now we can get started with creating our Arduino. So remember, the first thing that we need is we need our Arduino, of course. So what we can do is we can go to the right and find our Arduino. Remember, the way you do that is the right shows you all the elements that you can use. So like an LED, a resistor, but I don't want any of those. I just want an Arduino for now. So I can search for any component. So I can search, for example, an Arduino. I can click enter, and then I can see that our component here is the Arduino Uno R3. I can click and I can drag that in, and then my Arduino will be inside my project. So again, the way I did that was I just searched in the components tab for Arduino, clicked and dragged and inserted my Arduino. And so now the next thing that I need, which we discussed that we're going to be using today, is the breadboard, right? The breadboard allows us to combine electrical components, put it in one place, and then we can connect to it with our Arduino. So it's kind of really easy to connect lights, motors, anything else we want to use. So resistors, for example. So what we're going to do is we're going to start finding our breadboard and put that into our project. So the first thing I'm going to go ahead and do is I can search for breadboard in my components. So I can, instead of Arduino, I can just click this X, and then I can search for breadboard. And there's different types of breadboard that you can use, but the breadboard that I personally want, and the one that we're going to use for today, is the breadboard small. I can just click and drag, and you can see it's like this white components. Sorry about that. Okay, so anyways, you can see it's this kind of like white kind of brick that we can just use. And if you guys want to zoom out as well, you can just do this to zoom, or just do Control minus, and I'll just zoom out if you guys want to see better. So the first thing I need to do from here is remember that the breadboard connects to the Arduino, and what we use in all of our Arduino projects to connect things together is wires. So the first thing I need to do is use a wire to connect my Arduino to my breadboard. So the first thing I'm gonna go ahead and do is remember that ground will give us the power for our Arduino. So we wanna connect the ground to our breadboard. So the first thing I'm gonna go ahead and do, you can see that, remember that on the Arduino, we have certain pins. So you can see like there's ground, there's 13, there's 12. And then on the other side, there's more pins as well, right? Over here, there's other pins that we can use. So I'm gonna go ahead and connect ground over here. This one, I can just select the pin and I can easily access it. So I'm gonna go ahead and select ground, and then I'm gonna drag that up, and I'm gonna select, I'm gonna connect it to my Arduino, to my breadboard. So the first thing I'm gonna go ahead and do is I'm gonna click ground. I'm gonna drag that all the way over, and I'm gonna select this minus sign. And the only thing we're really doing here is we're trying to make this go inside a loop. So it's just gonna go power to minus, then go to plus, and then return back to Arduino. So we want it to be a complete full circle. Don't really worry about the minus and the plus, but just remember that we're trying to make this a complete circuit. So all we really did is, remember the way we can connect wires is we selected the ground pin, and then we dragged that and selected our minus on the breadboard. And then the last thing that we're going to do in terms of connecting our Arduino is that we're going to go ahead and select 5 volts over here. We're going to go ahead and select 5 volts. And then we're going to drag this over and then connect it to the plus sign. And if all you really know about 5 volts is 5 volts just stands for how much electricity we're putting into the Arduino. So this time, all 5 volts really does is it'll put power into the breadboard. Again, don't really worry about what exactly the volts are doing and what minus and plus means. Just remember that we're trying to make a complete circuit, and these wires help power the breadboard and the Arduino. I'm gonna wait just maybe 30 seconds for everyone to get there. I just want to make sure everyone's caught up. If you have any questions again about whatever we're doing, again, the Q&A is always open. Okay, and so now what I want to do is remember that usually we had, from last time, what we had is we had our light, then we had the resistor, and then the resistor connected to the Arduino. So what we want to do today is we want to have that exact same setup, but we want to have 3 lights instead of 1. So remember, lights is a very simple, LED is a very simple way of saying lights. So we want 3 LEDs connected to our Arduino. So the first thing we're going to go ahead and do is we're going to add our LEDs or our lights. So again, we can go to the right. We can just click the X, and then you can see the LEDs already over here. We really don't need to search for it, so we can just click and drag that in. And this time, instead of connecting this over to our Arduino, we can just put that into. You can see how the LED can move around in any of these pins. So I'm just going to connect this to the top over here on 13. And then what I can do from here as well is, since I want 3 lights, I can put this another LED, maybe one space right next to this other LED, and I can do that for another LED as well. And so remember, all that we're doing here is we're just connecting our small LED lights to the breadboard, and then we're going to connect our Arduino to the breadboard, and then from there, our circuit will be complete so that the 3 lights can flash. And then if you remember how our last project was set up, we had the LED over here, and then we had a resistor right underneath it, and then we had a wire connecting from this little pin over here to the Arduino. So we're gonna have a very similar setup this time, except this time, since we're connecting to a breadboard, it's gonna look a little bit different. Okay, so now what I want to do is I want to go ahead and put in my resistors. So the first thing I'm going to do is I need a resistor for each one of my LEDs. So I can click and drag a resistor into this. And what I really want is I want to keep one pin on the minus sign. You can see that there's 2 sides to this resistor. One can go inside, one I want inside my minus, and one I want on the other side of the breadboard. And again, all this really will do for us is that one side of the resistor will be put into power and the other will be connected to the LED. Okay, so now all I really need to do is I need to add 2 more resistors under each one of my LEDs. I can just click and drag. And what you want to make sure of, and I want to point this out as well, is that you want to make sure that the resistor is right underneath the left leg of the LED. So you can, for example, the resistor over here is aligned with the left of this LED, same with this resistor, and same with this resistor. I know we're going through a lot of steps right now, and it may be confusing, but again, we're here to help you guys. So if you have any questions, the Q&A is always open. And remember, the resistors just control our voltage. So all it really does, it'll just make sure that the Arduino does not burn out. And then just like we did last time is we can start connecting our wires to our LEDs. Now, the good thing about using a breadboard is that we don't need to necessarily connect one wire directly to the LED, but instead we can just connect it to the breadboard, and then the electricity will travel through and hit the LED. So for example, I want to have pin 13 connected to my first LED. So I can go ahead and select pin 13. I can click and drag that right in. And then similarly, if I want pin 12 connected to my second LED, I can click and drag that in. And then for example, if I want pin 11, I can click and drag that in. And this may look a little bit weird since the wires are crossing each other, but you can always just move it over and it'll just work that way. But other than that, that is essentially all we have for the hardware part of this project. Again, we used the breadboard, we connected our LEDs, we put in our resistors, and then we connected the wires to the Arduino. And then after this, Sun will be going over how are we going to program and kind of do just make sure that this project works by bringing it to life with code. So San will explain that in just a moment, but I'm just going to keep this up for maybe another minute to make sure that everyone can look at this and then connect any wires if they missed one or any components need to be placed wherever. Just make the adjustments as needed, but I'm just going to leave this up for maybe another minute. And also just remember that in case you missed it, we want our ground over here connecting to the minus sign and the 5 volts over here connecting to the plus sign. And just remember, as I mentioned before, make sure that your resistor is aligned to the left of the LED. That just makes sure that it's going in a straight direction and it's a complete circle. Okay, so now we're going to go over to Sion, who's going to explain how we can bring this project to life with code.
Yep. So I'll just wait maybe another minute because I think some people are just almost there. They're just catching up a bit. And I know we're going a little bit fast, but we're just trying to make sure that we get everything done before the end of class. But I know a lot of people are close to getting to the point where we are. So if you're there, why don't you just type in the chat, type yes in the chat. I just want to see where everyone is right now. If you are at the screen where you can, you've placed all the wires, the LEDs, and the breadboard and the Arduino, and you've signed in and everything, just type yes. Okay, so I see a lot of yeses, but I also see a few nos. So I'll just wait maybe one more minute. And in the meantime, I'll just share my screen. All right, so everyone should be where I am right now. If you aren't, that's fine. We do put a recording of this, and I know we end in just less than half an hour. So if you want to catch up here, it's completely fine. If you had some trouble, make sure to ask us ask us if you have any questions. Some people did have some trouble signing in, a couple people, and that might be because um, I most likely I'm sure everybody typed in the class code correctly. If you do not know the class code, you don't need to ask in the Q&A. Instead, just um, go to the chat. Soho will type in the chat right now because I know it's too much to scroll up. So Soho will type in the class code in the chat for people who have for some reason been logged out. Um, and once again, I'll share my screen right here. So if your username will be here, if you don't have a username, if your name is not here, this is the only place to find your name or your nickname. And that's the place where it asks for your name after you've typed in the class code. If you can't find it here, just type it in the Q&A and say you don't have a username, and we'll make one for you. And hopefully by next class you can also do it. But if you don't have a username, just type in the Q&A that you don't have a username, and we'll make sure to make one for you right away, and so you can go ahead and get started with the project. So as people are just catching up, I'll quickly just explain a little more in depth of what this means. If you want, when you're at home, or if you want later on, you can go ahead and add more LEDs if you want. I'll teach you how to make sure that they work all together, and add more resistors. You can play around with all the components here. Over the next couple of weeks, we'll be getting to more stuff, more components, making the projects a lot cooler, and it'll be more than just LEDs. So if you want to play around, that's completely fine. But just as an intro, you guys can see that we have an Arduino here, and you can move it around. But the main two wires I'll just focus on for right now are these two wires here. And it's a little bit confusing because they're crossing each other, but if you can see correctly, this positive end right here, the positive wire right here is connecting to the 5 volts. And 5 volt, it's kind of hard to explain because we have a lot of different levels of understanding, because we have all the way from 3rd to 8th graders here, almost 100 students in the call. So it's hard. I'm not going to go over specific complicated things because it'd be easier for me to explain something easier, simple. But basically 5 volts is just power, like electricity. That's how all of this is working, because the Arduino, like we said before, is just a board that allows us to write code and program an LED. We could turn it on, we could turn it off, right? So to do that, we need electricity. And the only way to do that is to connect this wire to the positive end. And it might not make sense right now, but as we do more projects in the next couple of weeks, it'll make a lot more sense. But basically, the 5 volts is connected to positive, and then what happens is the electricity flows and it goes through these wires. It's connected to it's flowing through the resistor. Because there's so much electricity, you don't want it all to just go into the LED. That's why the resistors are there. And so that's might be a little hard to understand. If you don't understand it, that's completely fine. But the resistors just help the LED turn on. That's the best way to understand it. And there's just multiple LEDs, so there's multiple resistors. And so the wires, you can see that for each LED, there's one wire, and it's connected to a different pin, right? Like that's what we said before. The pins right here are supposed to be connected to the Arduino board. And so that's all you need to understand for now. And we'll definitely explain more of how this works next time. But the main thing I'm going to get to is the code here. So if everyone goes to if everyone you'll be on the screen, and you'll see on the top right on the bar, there's something that says code. And so it either might pull up to blocks or it might pull up to text. I'll go ahead and go to blocks and text. And so it's up to you what you want to do. As you can see, this is our code from last time where it just turns it on and off. But since we have multiple LEDs this time, we need to do this to multiple we need to do this to each of them, right? So what we're gonna do, the first thing we want to do, and I mentioned this last time too, and that's that we need to set up a pin. So if I'll quickly close the code here, you can see that each LED is connected to a pin, and so this LED is connected to pin 13, right? So there's pin 13, there's pin 12, pin 11. And that's how the Arduino knows which pin to turn on or off. Since there's multiple LEDs, it wouldn't know which one to turn off if you just say turn the LED off. If I told you turn the LED on, you wouldn't know which one. And the only way to do that is by telling it turn LED number 13 on or turn LED number 12 on. That's the only way to turn it on. So the first thing we want to do, and if you're using blocks, you don't really have to do this, but if you're using text, that's the only way to do it. Go to, okay. So if you're over here, this is more of a blocks type format. So you can do either one, but I'll do text for now, just so you guys can understand. And so just go to setup. And like I said, this just tells the Arduino that these pins exist, these LEDs exist. So to do that, you're gonna just copy this line right here and just type pin mode, and make sure the pin is all in lowercase, but the mode, the M start is a capital letter. Pin mode, we can do 12, comma, and then you'll do output, and that just tells the Arduino that we're using this pin or this LED. And then at the end, I didn't talk about this a lot last time, but at the end of every line of code, there's supposed to be a semicolon. And so I know a lot of people are not familiar with text-based programming or just text instead of using blocks. And so a lot of programming languages, which is, in this case, this is Arduino C. And it's not really like a famous programming language or anything. It's just used specifically for an Arduino board. At the end of each line of code, you just have to put a semicolon that tells the Arduino or the computer that that's it. That's the end of the line of code. If you don't do that, you'll get errors and it won't work. But make sure that after every line of code, you're typing in a semicolon. And then we'll just do this again. You can literally just copy it and paste it here. That just saves time. You're gonna write pin mode 11. So now we have 13, 12, and 11 here. So that just works out. And so the next thing we want to do is we want to turn it on and off. Like you can see here, right now we're turning the pin 13 on. We're waiting 1 second, and then we're turning it off. So in this case, we also want to turn the next LED on and off. And so to do this, you can see here, I'll just move this comment. We want to turn the next line of code. We want to use the next line of code to turn, let's say, pin 12 on. So we'll do digitalWrite. Make sure you're spelling it correctly like it is above. digitalWrite 12, comma, high, which means I'm turning LED 12 on. Wait 1 second, so I'm going to do a delay of 1,000 milliseconds. And if I'm going too fast, sorry about that. I'll try to explain and just slow down a bit, but I'm also trying to explain everything thoroughly as well, so that might help you to give more time to write it all down. But we also provide a recording in case you miss out on the code. And so since you've turned LED 12 on, the next thing to do is to turn it off and then go to the next one. So we'll turn this exact same one off. So we'll turn pin 12 off, and then next thing we'll do is we'll turn the next LED, which is pin 11, on. So digitalWrite, and you can literally just copy the line. You don't really have to type it all out. I'm just typing it out so that people can understand. Oh, actually, my bad. We need to put a delay first. So we'll delay it for 1 second. So just write 1000 because 1000 milliseconds equals 1 second. Make sure to put a semicolon. Then we'll go on to turning the next LED on. So we will be writing 11 comma high. So that turns it on. Put a semicolon. We'll wait 1 second, which is 1000 milliseconds, and then we'll turn it off. So digitalWrite low. And once again, high means on and low means off. And I believe you can also do this with blocks too. So I've done it with text here. If you also did it with text, but you prefer blocks, it'll probably just convert everything to a block. Or actually, oh no, apparently it does not. But it's the same logic here. So if I go back into the text, okay, so it didn't save. I don't know why it does that, but okay. All right, yeah, okay. So yeah, that's also another problem, I guess. They have this kind of bug, but I guess you can't really switch in the middle. So I think you have to stick with one of them. But that's all right. I actually typed in all of this like that. So you can actually just copy this like that. And then just replace it. So you can do 12, 12, 11, 11. Yeah, so that'll work perfectly fine. And then you can just click start simulation. I'm not sure if this will work, but so it turns the first one on, turns it off, turns this one on, turns it off, turns this one on, turns it off. So you can see the first one's on, turns it off, waits 1 second. So that's kind of how it works. Unlike last time we were only turning one LED on. This time we're turning on multiple. I can also, I believe, let me just search up LED. So I think there's also an RGB LED that you can use, but we might get into that in a later project. This is just a simple version of this.
Yeah, and also you can the RGB LED we're going to be using later on in the next 2 weeks. But if you want to change the color of your LEDs, you can just click on the LEDs, and then in the top corner where it says the color, you can change that to orange, yellow, blue, whatever you'd like. So I can change it to like green or yellow, and then it'll work from there as well. And then if you want your LEDs to appear a little brighter, in the pin mode, you can add in the pins that you're using.
Yeah, and that's kind of just something to remember. So like I said, it kind of deleted all my code here, so I'll redo it. But the pin mode is very important because if you really had an Arduino in real life, this would not work if you didn't have a pin mode. That just tells the Arduino or the computer that we're going to use this LED. So if you don't really do this, it's just going to ignore these two LEDs. It's going to pretend like it doesn't exist. And so these commands won't work. So make sure that you write the pin mode in setup. And you can see that there's a two different sections of code here. There's the setup and there's the loop. And they're both put in brackets. And so all the brackets do is just make sure that it executes that code. So this thing that says void loop basically loops this forever and just keeps on doing it. So it'll do all these lines of code, then come back to the top here, not all the way top, just into this part and just keep on looping. However, this setup thing just does this once. So it's set up, runs these lines of code once, stops, moves on to this, and this just loops on forever. So I'll just quickly do this. And if we start the simulation, you can see it will be a lot brighter. We have a red, yellow, green, yellow, and red. And you can also do different colors. You can change it to orange. You can change it to blue. Any different color you want, but I'm just kind of mimicking a red light or a stoplight. Yeah. And yeah, so that's pretty much it. If you wanted to do a block, or if you want to use blocks, it's a very similar thing. You don't need to worry about setup. You just need to worry about turning it on waiting 1 second. You don't want to write 1000 because in the blocks, it only uses seconds, not milliseconds. And then do this all over again. But if you want to challenge yourself, I'd suggest using this because you're using text-based code because it's a lot easier to understand sometimes. But if you prefer using blocks, that's completely fine. Anyways, I'll just keep this up for just a couple more minutes, and then we'll move on to the next thing, which is just Q&A, and just talking about a couple more things. But other than that, just make sure that you're at this setup. You've got all the LEDs components done. You have the code written. So just make sure you do that. And I'll just wait 1 minute for everybody to catch up.
I think some people are having trouble with editing the text. So Sun will show you guys how to access the code again and then edit the text.
Yeah, so I'm not going to exit out, but if you're on code, you can switch out to a different, so I'll stop the simulation. You can switch to a different thing like blocks or text. If you are on blocks and text, what that function does is you can only manipulate the block, so you can change it to, I'll actually just quickly show you. If I go to blocks and text, it will delete your code, so just make sure you copy it somewhere, click continue. So you can see you can't really edit this, and that's for a reason because if I do, for example, let's see, like that, it'll automatically add the code over here. And if I delete it, you can just click on it and click delete, or actually just drag it to the trash. It'll delete the text-based code as well. So that's the only thing you need to know. You can't really edit it, but if you want to edit text instead, just go to text and do that. And I'll just paste in what I had before and then start the simulation.
Yeah, and a lot of the times it will usually not let you edit the text. This is very important to know. Sometimes it won't let you edit the text since you're running the simulation. So make sure to stop your simulation and then you can go ahead and edit the text.
All right. It's almost 5 o'clock. We end at 5:15 usually, and that's just 10 minutes to answer questions. So I'll go ahead. I'll keep the screen up, and we'll go ahead and start answering questions, and then later on I'll stop it. Let's see. Okay, so some people are saying I did the same code, but it does not work. Make sure you have the hardware right, or sorry, the wiring right, because the code will only work if you actually have this setup right. So make sure that this negative wire is connected to the ground or GND. That just makes sure that the entire loop is connected because you can't have an open loop. You have to have it all connected or a circuit. Make sure that each of these wires are connected to the right spots. The LEDs are connected to the right spots. If you do that, most likely everything will work as long as your code works as well. Yeah, and so like I didn't do this before, but if you don't set up the pin mode, it won't be as bright, which is kind of a weird thing to do, but that's how it works. So that's just a weird bug. But make sure that you're doing pin mode because in real life, if you do get an Arduino, it won't work at all. And also later next week, we'll probably suggest a link for people who are interested. They can just buy their own Arduino, and it comes with all these different components like a motor and an LED, an LED that can turn any color of your choice. So it's not like a specific color, but it can change to any color you want. So there's a lot of really cool electrical components that you can go with out there. And there's a specific Arduino package that we'll suggest to you guys, and you guys can buy it if you want to.